Welcome to Astronomy Daily, your daily guide to everything happening in space and beyond. I'm Anna, joined as always by Avery, and it is Monday, April 20th, 2026. Welcome everyone, wherever you're tuning in from.
And what a weekend it was in the space world, Anna. Big things happened while some of us were sleeping.
You are not wrong. Today, we have 6 stories that cover the full spectrum, from a rocket that pulled off a historic milestone and then immediately ran into trouble, to some genuinely beautiful planetary science that will make you look at Saturn a little differently.
Blue Origin is going to be the talk of the industry today. Big booster landing and a satellite in the wrong place. Stay with us.
Let's get into it.
I'm ready if you are.
Our lead story today takes us to Cape Canaveral, Florida, where yesterday, Sunday, April 19th, Blue Origin made history, and then a few hours later had a very bad morning.
The roller coaster that is rocket science.
Exactly. Let's start with the good news. Blue Origin's New Glenn rocket lifted off at around 7:25 Eastern Time yesterday on its third ever mission, designated NG-3. But here's what made this one special. For the first time ever, Blue Origin was flying a previously used New Glenn first stage. The booster, nicknamed Never Tell Me the Odds, had already flown once before, back in November last year on NG-2.
I love the booster names, and reusing an orbital-class rocket is genuinely a big deal. SpaceX has been doing it routinely for years now, but this was Blue Origin's first time proving New Glenn can come back and fly again.
And it did exactly that. About 3.5 minutes after liftoff, the first stage shut down and separated. 6 minutes in, Never Tell Me the Odds came down and landed cleanly on Blue Origin's drone ship Jacqueline in the Atlantic Ocean. Jeff Bezos shared video of the landing on social media, and Elon Musk, to his credit, offered congratulations.
That's a sentence I didn't expect to say today.
And yet, here we are. Now, the bad news, about 2 hours after launch, Blue Origin posted an update saying the upper stage had placed the payload, a BlueBird 7 satellite for AST Space Mobile, into what they called an off-nominal orbit, which is aerospace speak for the wrong orbit.
How wrong?
Lower than planned. AST Space Mobile confirmed that BlueBird 7 had powered on and separated from the rocket successfully, but the altitude was too low to sustain operations. Their onboard propulsion couldn't compensate for the shortfall. And so the decision was made. BlueBird 7 will be deorbited. It'll burn up in the atmosphere.
That's a significant satellite. BlueBird 7 was meant to deliver direct-to-smartphone cellular broadband from space. It would have joined AST's growing constellation. The good news is the satellite was covered by insurance, and AST says they have BlueBirds 8, 9, and 10 nearly ready to ship, expected in about a month.
And AST Space Mobile maintains their target of around 45 satellites in orbit by the end of 2026 across multiple launch providers. So this is a setback, not a disaster. For Blue Origin, they've proven the booster works. They now have some explaining to do about the upper stage. This was New Glenn's first payload loss, and the investigation will be closely watched.
The rivalry with SpaceX continues, and for now, SpaceX's record on payload delivery is something Blue Origin needs to match.
While Blue Origin was making news for all the wrong reasons with its upper stage yesterday, this morning, SpaceX provided a tidy contrast, a clean, routine launch of a GPS satellite for the United States Space Force.
The kind of missions SpaceX almost make look boring at this point.
In the early hours of this morning, Monday, April 20th, a SpaceX Falcon 9 lifted off from Space Launch Complex 40 at Cape Canaveral, carrying GPS-3 Space Vehicle 10. This is the 10th in the next generation GPS-3 series, which delivers 3 times better accuracy and up to 8 times improved anti-jamming capability compared to older GPS satellites.
GPS touches everything: navigation, financial transactions, emergency services, military operations. These upgrades matter enormously, even if the launches don't generate the drama of a Blue Origin mishap.
The Falcon 9 first stage returned to land as expected. Clean mission, clean delivery. SV-10 joins its predecessors in the GPS constellation, which serves billions of people and devices every single day. Sometimes the best rocket stories are the ones with no surprises.
If you've been following along with Astronomy Daily over the past few weeks, you'll know that the Artemis 2 mission has been one of our biggest editorial threads this season. The crew of 4 splashed down on April 10th after a 10-day journey that took humanity back to the vicinity of the moon for the first time since 1972. And now we have some important post-mission news. The heat shield appears to have done its job.
This is a big relief for NASA. The heat shield on the Orion capsule, named Integrity by the crew, had a known design flaw going into the mission. After Artemis 1's uncrewed test flight in 2022, engineers found that the Avcot ablative material had cracked and broken off in ways they hadn't predicted. There was significant debate about whether to fly Artemis 2 with the same heat shield.
NASA ultimately decided to proceed, but with a modified re-entry trajectory, steeper than originally planned, to reduce the time the shield spent at peak heating temperatures. And that decision appears to have paid off. Artemis 2 Commander Reed Wiseman led the crew in a visual inspection of Integrity shortly after splashdown, and his assessment was encouraging. There was some char loss on the shoulder of the capsule, but the underside, which takes the brunt of re-entry heating, looked, in Wiseman's own words, wonderful.
He said the crew just leaned under and looked at it, and 4 humans were satisfied with what they saw. That's a good sign. There was also social media speculation about a white patch visible in post-splashdown images, but NASA Administrator Jared Isaacman addressed that directly. The discoloration matched expected behavior in the compression pad area and had been replicated in pre-flight testing. No unexpected conditions.
A full engineering data review is still underway. This was not an uncomplicated heat shield, and NASA will be thorough in analyzing the re-entry data. What we can say today is that all 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Canada's Jeremy Hansen, came home safely. And NASA has confirmed this was the last mission for this particular heat shield design. Future Artemis flights will get a redesigned thermal protection system.
And Artemis 2 Commander Wiseman has said the mission bodes well for returning astronauts to the lunar surface. His words, "It's absolutely doable, and it's doable soon."
Onwards and upwards, literally.
Time for some beautiful planetary science. Saturn's moon Titan is one of the most extraordinary places in the solar system. It has a thick atmosphere, rivers, lakes, and seas. The catch is that those seas are not water. They're liquid methane and ethane, hydrocarbons. And a new study published in the Journal of Geophysical Research Planets has just given us our best picture yet of what the surface of those seas actually looks like.
Which is waves. Enormous, surreal waves.
Enormous and slow. Researchers from MIT and the Woods Hole Oceanographic Institution developed a new wave modeling tool called Planet Waves. And when they applied it to Titan's hydrocarbon seas, the results were striking. On Earth, you need a decent wind to build significant waves. On Titan, a mild breeze, the kind you'd barely notice, could generate waves more than 3 meters tall, or over 10 feet. But here's the catch. Because of Titan's lower gravity and the different physical properties of liquid hydrocarbons compared to water, those waves would move in slow motion.
The lead author describes it perfectly. She says it looks like tall waves moving in slow motion. If you stood on the shore of one of Titan's seas, you'd feel only a soft breeze, but you'd see these enormous rollers coming toward you. It would feel completely wrong, deeply alien.
And the Planet Waves model didn't stop at Titan. The team also modeled wave behavior on ancient Mars, back when it had liquid water, and on 3 exoplanets. One is a cool super-Earth called LHS 1140b, which may have oceans, but whose strong gravity would suppress wave height. Another is a Venus-like world with lakes of sulfuric acid, where only very powerful winds would generate even ripples. And then there's 55 Cancri E, a lava world. an ocean of molten rock with gravity so strong that even hurricane-force winds would produce barely a ripple.
This model is also genuinely useful for mission planning. If we ever send a floating probe to Titan and NASA's Dragonfly rotorcraft is heading there, engineers need to know what kind of wave forces their hardware will face.
Titan continues to surprise us. Every new model, every new instrument, every new angle, this moon just keeps getting more fascinating.
From alien oceans to our own night sky, because this week is a great week to be a stargazer in the southern hemisphere, and really anywhere on Earth.
The Lyrids are back.
The Lyrids are back, one of the oldest recorded meteor showers in history. Observations go back approximately 2,700 years. The Lyrid meteor shower peaks in the early hours of Wednesday morning, April 22nd. And this year, viewing conditions are nearly ideal.
The reason is the moon. After months of meteor shower droughts, the first significant display since the quadrantids in early January arrives this year with a crescent moon that sets after midnight. So from about 1 or 2 in the morning on Wednesday through to dawn, the sky will be beautifully dark.
For our listeners in Australia and New Zealand, that means a Wednesday morning, April 22nd, from around midnight or 1 a.m. onwards is prime time. Find the darkest sky you can, let your eyes adjust for at least half an hour, and look toward the eastern sky near the constellation Lyra, though the meteors themselves can streak anywhere across the sky. You're looking for up to 15 to 20 meteors per hour under ideal conditions.
The Lyrids are caused by debris left behind by Comet Thatcher, which takes about 415 years to orbit the Sun. It was last in the inner solar system in 1861 and won't return until around 2276. So the shower is a gift from a comet that none of us or our grandchildren's grandchildren will ever get to see directly.
And the Lyrids are known for producing bright fireballs, not as frequently as the Perseids or Geminis, but they do happen, so it's worth staying out for a while. If you see something spectacular, share it. We'd love to hear from you.
Our final story today takes us to the future of ground-based astronomy and a pivotal moment for one of the most ambitious telescope projects ever conceived. The Giant Magellan Telescope in Chile has just entered its final design phase, ahead of a critical funding decision that will go before the United States Congress.
This is a telescope that could genuinely change what we know about the universe.
Let's set the scene. We are living through the era of extremely large telescopes, a generation of observatories with mirrors in the 20 to 40 meter range that will dwarf anything currently in operation. The European Extremely Large Telescope, under full construction in Chile, has a 39-meter primary mirror and is on track to enter service in 2029. That will be the largest optical telescope on Earth.
Then there are the two American entries, the Giant Magellan Telescope, GMT, being built at Las Campanas Observatory in Chile, with a 25-meter aperture made up of 7 enormous mirror segments, and a 30-meter telescope, also American-led. Both face more complex funding situations.
The GMT entering final design phase is a significant milestone. It means the engineering is mature and the project is heading toward construction readiness. But the money needs to come through from the NSF. The science case is extraordinary, detecting Earth-like planets around nearby stars and studying their atmospheres for signs of life, probing the nature of dark matter and energy, looking back at the first stars and galaxies.
And the competition from China shouldn't be overlooked. China's Shenzhen Space Telescope is due for a 2027 launch and promises significant capability. The argument for funding the GMT is partly scientific and partly strategic. The United States has defined the boundaries of astronomy for decades, and falling behind now would have long-term consequences.
We will be following the congressional decision closely. For now, the GMT is moving forward, and the universe is waiting.
Patiently, I hope.
That's our 6 stories for today. Blue Origin's mixed morning, a clean SpaceX GPS launch, Artemis 2's heat shield giving us post-mission relief, slow-motion alien waves on Titan, the Lyrids about to peak, and the Giant Magellan Telescope heading toward its funding moment.
Before we go, trivia time. Here's today's question. The Lyrid meteor shower is produced by debris from Comet Thatcher. Approximately how often does Comet Thatcher complete one orbit around the Sun?
Think about it. And the answer is in today's show notes, along with links to all 6 stories.
If you're heading out Wednesday morning for the Lyrids, we want to hear about it. Find us at astronomydaily.io or at AstroDailyPod on the socials.
And if you're enjoying the show, please leave us a review. It genuinely helps new listeners find us. We'll be back tomorrow with more from the universe. Until then, keep looking up.
Clear skies, everyone.